Okay, let's talk about React Native. It's that framework that came along with this huge promise to completely unify mobile development. But in the process, it also kind of created this minefield of performance traps and some pretty serious security risks. So today we're diving into that duality, the incredible promise and the very, very real peril.
The dream is so elegant, right? A single JavaScript codebase that works on both iOS and Android. But that amazing efficiency, it comes at a hidden cost. We're going to go deep on the performance traps that can bring your app to a grinding halt, and we'll expose the security threats that could compromise, well, everything.
But hey, before we get into all the doom and gloom, let's just take a step back and remember why React Native became such a massive favorite for developers in the first place. It all comes down to a simple, really powerful promise: building beautiful apps way, way faster.
So, what's actually happening under the hood? Well, you can think of React Native as a kind of universal translator for your code. You write all your app's logic and design just once, using JavaScript, and the framework translates it to speak both iOS and Android totally fluently. So you don't have to. It's a really powerful idea that honestly changed the game. And this right here brilliantly shows how that core idea has just been supercharged. Tools like Expo Application Services, or EAS, have built this whole ecosystem around that promise. I mean, you can build an iOS app in the cloud without even owning a Mac. You can use EAS Update to push a critical bug fix to all your users instantly, totally skipping that long App Store review process. This whole system is designed for one thing: speed.
All right, but all that speed and convenience, it can definitely come at a price. The big push for rapid development often leads to some nasty performance issues that can really frustrate your users and just undermine the quality of your whole app. This is where that dream starts to meet a pretty harsh reality.
The question that keeps developers up at night. The app runs perfectly on your top-of-the-line phone, right? But for your users, it's a completely different story. For instance, you might have a complex animation that's super smooth on a new iPhone, but it makes an older Android device just stutter and drop frames like crazy. The cause is usually just a few common but very costly mistakes.
Now, check this out, because this is one of the most classic performance traps in the book. Using a basic scroll view for a long list, that's like causing a major data traffic jam. It tries to render every single item at once, even all the ones that are way off screen. Flat list, on the other hand, is the optimized, smarter way to do it. It only renders the items you can actually see. I'm telling you, this one choice is often the difference between a responsive app and a totally useless one.
And it's not just about how you display lists. The libraries you pick for things like animations can have an even more dramatic impact on performance. This quote here is from a direct, head-to-head comparison between two super popular animation libraries, Lottie and Rive. And the performance gap, it's just staggering. I mean, just look at this comparison. On the left, you can literally see the Lottie animation struggling. It's all choppy at 17 frames per second. But on the right, Rive is just cruising along at a consistent 60 FPS, which gives you that smooth, fluid feel. To a user, this isn't some tiny technical detail. It is the experience. It just proves that choosing a library without testing it first is a huge mistake.
Okay, another one of these hidden performance traps is your app's JavaScript bundle size. The bigger it gets, the longer your user is just stuck staring at a loading screen. Now, web developers have this cool process called tree shaking to automatically get rid of unused code. You can imagine your code is a tree, right? Tree shaking just shakes out all the dead leaves and branches. The problem is React Native's default bundler, Metro, doesn't support.
So what's the takeaway? You have to be the tree shaker. Look at this really simple change with the Lodash library. The import on the left, it pulls the entire 70 kilobyte library into your app, even if you only need one tiny function. But the optimized version on the right pulls in only that single function, which is less than 2 kilobytes. That small change can shave precious seconds off your app startup time, and trust me, that makes a huge difference.
But performance issues are just one part of the story. The real danger, the really ugly part, lies in the security vulnerabilities, the kind that can be exploited by malicious actors, turning a developer's helpful tool into a really dangerous weapon.
So let's talk about CVE 2025-11953. This is a real, documented vulnerability. It allowed an attacker on the same Wi-Fi network to run code on a developer's computer. I mean, think about that. An attacker could steal sensitive data, install malware, or even take complete control of the machine, all because the standard dev server was. And this is the detail that makes it so critical.
See, most dev server bugs are only exploitable from the same machine, but this one was different. By default, the server was listening for connections from the whole network, not just your local machine. It's less like leaving your door unlocked and more like giving a spare key to everyone else on the same public Wi-Fi. It's that bad.
Here's exactly how the attack played out. First, the attacker finds that exposed server. Easy enough. Then, they send a malicious request to an endpoint that's supposed to open URLs, but instead of a URL, they send a command. And finally, the server just takes that malicious input and without even checking it, runs the command. Just like that, the attacker has control.
This is it. This is the exact line of code that made it all possible. The server takes the body of the attacker's request, that's rec.body, and passes it directly to the open function without any checks whatsoever. It's a textbook example of an injection vulnerability. The lesson here? You can never, ever, ever trust user input.
Okay, so we've seen the power of React Native, we've seen the performance pitfalls to avoid, and the really scary security risks to be aware of. The goal here isn't to scare you away from it, it's to equip you. So let's talk about how to build resilient apps that are both fast and secure.
Look, building a resilient app really requires a defensive mindset. On the performance side, that means always choosing those specialized components like Flatlist and actually benchmarking libraries before you commit to them. On the security front, it means auditing your dependencies and using automated tools to scan for vulnerabilities before they ever get to your users. And wrapping it all up is the need to constantly profile your app on real devices, not just a fancy simulator.
Frameworks like React Native let us innovate faster than ever before. It's incredible. But with every new feature we add, we introduce more complexity. And you know what? Complexity is where performance bugs and security holes absolutely love to hide. As this whole ecosystem evolves, the challenge for all of us is to harness its power without falling victim to its perils. So the question we have to ask ourselves is, are we building our next great feature, or are we building our next great crisis?